Hello and welcome to lesson 5.1. So we're starting chapter 5 now, and in chapter 5 this whole thing is going to be built around doing things with polynomials, okay? And the first step of this chapter is just to add and subtract polynomials, which seems pretty simple, but the first question you might would have is, well, what the heck is a polynomial? It's actually pretty simple. If you were to study Latin, which I don't think many people do anymore, this breaks down into kind of two Latin terms here, poly and nomial, or just nome. Poly, I think a lot of people know means many. So we're studying something with many somethings. And nomial, this is a bit of a stretch, but what it means is to name or to term or to dub something. So we say that this really just means many terms. So when we're studying polynomial, we're talking about things with lots of terms or with terms to them. Okay, so polynomial, we're just thinking about terms. And we could have one, two, three, four, five, or many terms. Okay, we already talked about terms a few chapters ago. Actually, back in chapter 1, whenever we went to just combine like terms. Well, really, that's the skill you're going to need today. So if you can kind of think back to what it meant to combine like terms, um, you'll pretty much have most of the skill you need for today's lesson. Actually, that lesson, I think it was our first lesson on simplifying. That's actually going to be like huge in today's lesson. So if you feel good about simplifying, which I always break into two steps, D and C, DC, which is distribute anything that needs distributing and combine like terms, then you pretty much have today's entire lesson. I just would like to show you some examples to make sure we feel good about this. Okay, so get a pen here. So for instance, some things that you'll be required to do are to be able to just add two polynomials. So let me give you two polynomials. So here is one polynomial. Notice it is made up of three terms. Remember, if you've forgotten how to combine like terms, I would suggest you go back and watch lesson 1.1. But if you're looking here, remember plus signs and subtraction signs are what kind of shows us where we have a chop off between, a separation between two terms. So this is a term, 2x is a term, 3 is a term. So this is a polynomial with three terms in it, which is called a trinomial. And we're going to add to it another polynomial. 5x to the third minus 4x squared minus 5x minus 2. Okay? And so we would like to be able to simplify this or add these two polynomials together. Well, if you look at this, what I have is some terms, a plus sign, and some more terms. And if I'm just adding two sets of polynomials, these parentheses are really and truthfully worthless. I can just drop these parentheses and then I just have a bunch of terms to try to combine. Now remember, when combining like terms, what we're going to want to do is just find the things that are like. That brings up a good question. What makes terms like? Well, this term right here, if we ignore the coefficient, that's the number in front of the term, and we look at what's left, what we have is an x to the third. So if there's anything else that's identical in the variable part, as far as variable and exponent, then that is a like term. So if we look, 2x, 3, 5x to the third, there is another one with an x to the third, an identical term. Because those are the same, I can combine them. Now, we always need to look out front just in case, because remember, the sign directly in front of a term belongs to it. For instance, this 3, this negative or subtraction sign, belongs to this 3. So this one doesn't have a sign, which means positive. So positive 2x to the third plus positive 5x to the third. And how do we add terms? Well, you leave the term part alone. They had to be like at x to the third. And we add the coefficient or subtract the coefficient part. So the 5 and the 2, 5 plus 2 is 7. All right. Now it is proper to go in what's called decreasing order. I will not take off if you write yours in any order, but because I was attacked and beat up by the teachers when I was coming up, if I didn't do this, I do it out of fear, and so that's a joke. But So next, I have an x to the third. Next, let's see if we have any x squared terms, just to keep counting down. Let's see, this is a plain x term, plain number. Oh, there's an x squared term. And make sure you grab the sign in front of it. Let me use a different symbol here. Grab the sign in front of it. No more x squared terms. So minus 4x squared is going to come on down. There's nobody to combine to this term. So negative 4x squared, or you can think of it as minus 4x squared, whichever way you want to think of it. So now I'll look for plain x terms. And I see I have a positive, or a plus 2x, and a negative, or a minus 5x. Those are both x terms, so they can be combined. And positive 2 and negative 5, if you add those together, makes negative 3. They are x terms, so negative 3x. Finally, I have just the plain numbers. Negative 3, negative 2, if you add those together, is going to be negative 5. Now, if you look at what we have here written, there's no terms that are like. Everything is simplified as far as we can go, and so we're finished with it. Well, geez, that does feel a lot like what we did in section 1 of the entire course, just combining like terms. Let's look at maybe 2 more examples of that before I lead us into a slightly different direction. Okay, so that was adding 2 polynomials. How am I going to handle subtracting 2 polynomials? So let me give us a good example here. Let's see. So here's one polynomial, 6x squared minus 3x plus 2 minus 10x squared minus 5x plus 10. All right, now the thing here that's different, when we were adding polynomials, we could just drop the parentheses. But when I'm subtracting, I have to be very careful with this. This is that point where I would like you to add a 1 and say, oh, I need to distribute this negative sign to everybody back here. There's nothing to distribute on this first one, so I'm going to drop the parentheses from the first polynomial. And I'm going to take the time to distribute this negative 1 to everybody in the second polynomial. So negative 1 times a positive 10x squared makes a negative 10x squared, or a minus 10x squared. Negative 1 times a negative 5x makes a positive 5x, because a negative times a negative is a positive. Negative 1 times a positive 10 makes a negative 10, or a minus 10. Okay, so now that I've done that, the problem comes down now to just combining like terms again. So wait, that is the same thing we did in section 1. I distribute and then I combine. That's really easy. So let's find my like terms. 6x squared minus 10x squared, that's negative 4x squared. Because positive 6 minus 10 is negative 4, and they're both x squared terms. I have a plain x term, negative 3 plus 5x, negative 3x plus 5x. That is positive 2x. And then I have positive 2 minus 10. That is negative 8. Okay, so that's not really insanely hard. Let's do one more example. And then we will, like I said, move into kind of a different feeling topic here. So let's see. Let's go with 3. We'll move a little bit faster. 3x squared plus 5x minus 6 minus 4x squared minus 2x minus 10. And so of course we looked that we're subtracting, so I'm going to want to distribute a negative 1. No need to worry about the first polynomial. We can leave it alone and distribute this negative 1. So minus 4x squared, negative times a negative makes that a plus 2x, and a negative times a negative makes that a plus 10. So I did that pretty quickly, so if you need to pause and think about each step that I did, mainly paying attention to these 3 signs very carefully there. All right, let's combine like terms. 3x squared, negative 4x squared. That would be negative 1x squared. Do I need to show a 1? No, I don't have to show a 1. If you do, I won't take off, but it's not proper. Plus 5x and plus 2x, that'd be plus 7x. Minus 6 plus 10, that'd be positive 4. Okay, so hopefully you're feeling pretty good and you see how fast we can do these without really much stress. That was really easy. So now what we're going to want to do is, since we're dealing with all these polynomials, we're going to want to start kind of intertwining some stuff we already know. We would like to start combining some function notation in with these polynomial operations. So let's say that I have a function f of x, which is the polynomial 2x squared minus 2x plus 3. And let's define another one. So, and let's let the function g of x, let's let that be x squared plus 5x plus 4. And what we can do is we've defined these functions. I could ask you questions like this. Hey, could you find me f of x plus g of x? I can perform operations on these functions because these functions are polynomials, and I know how to perform operations on polynomials. All this is asking you to do is add the function f plus the function g. So let's take the function f and write it down. 2x squared minus 2x plus 3. And it might be good, proper technique to put this in parentheses when we write it down. Plus, and then let's write down the function g. X squared plus 5x plus 4. Oh, well, this is just what we've been doing the whole lesson. I'm just adding two polynomials to get this thing here. That's not hard. So I can drop the parentheses and just combine like terms. 2x squared plus x squared, that gives me 3x squared. Negative 2x plus 5x is positive 3x. Positive 3, positive 4, that gives me plus 7. Okay, well that was really easy. Maybe we should ask one more. I think what I will do though first is shrink this down. I went kind of fast because we should be getting faster at these. And you should be feeling comfortable. If I went too fast, pause the video and take some time to kind of stare at it and make sure the steps make sense. If they don't, then you can email me and ask me a question. All right, let's do another one. Okay, one more example here. What if I were to ask you to do f of x minus g of x? Oh, well, we should know how to do that as well, right? Let's just write down what this is asking us. So I got the function f of x. Let's put it in parentheses. 2x squared minus 2x plus 3. And then what I have is a subtraction sign, and then the function g of x. So let me write down what g of x stands for, and it stands for, represents x squared plus 5x plus 4. Okay, I think this is not too bad or too difficult either. I just need to do what I've been doing throughout the course, and I need to distribute this negative sign. So I'll bring down the first polynomial. I'm not really going to mess with it besides dropping the parentheses. And we'll distribute this negative 1. So that'll become negative x squared, negative 5x, and negative 4. Okay. So if I could just combine like terms, I should be finished. So I have 2x squared minus x squared, which is a positive 1x squared, or positive x squared. I have negative 2x minus 5, which is negative 7x. And I have a plus 3 minus 4, which is negative 1. Nice. All right, like I said, I'm going a little bit faster with some of these things because we kind of should be building throughout this lesson. But that's all I have for you today. So we just were trying to get comfortable with adding and subtracting polynomials. And I wanted to show you that we could play with functions and function notations to ask you to add and subtract polynomials in the same way. But I'll see you next time. Take care.